Today, we are gonna talk about the topic of predicate logic. What is a predicate logic? It is also known as the propositional function or open sentence. It is a proposition whose truth value depends on the value of the subject of a statement. It is expressed as P of X. What is a domain or universe of discourse? It is the set from which the value of the subject X may be chosen for a given P of X. What is a quantification? It expresses the extent to which a predicate P is true or false for all possible values in the universe of discourse or for some values in the universe of discourse. There are two types of quantification. The first one is universal quantification. It is represented by upside down A, which means for all. For all xp of x, if and only if p of n sub 1 conjunction p of n sub 2 and so on. Second is existential quantification. It is represented by backward E, which means there exists. There exists x p of x if and only if p of n sub 1 disjunction p of n sub 2 and so on. Often, we want to talk about properties of things, not just atomic propositions. All lions are fierce. Some lions do not drink coffee. Therefore, some creatures do not drink coffee. So, let X range over creatures. Write L of X for X is a lion. Write C of X for X drinks coffee. Write F of X for X is fierce. For all X, L of X implies F of X. There exists X, L of X, conjunction negation of C of X. There exists X, F of X, conjunction negation of C of X. So, we extend the language. Variables X and Y ranging over some specified domain. Atomic predicates A of X and B of X like the earlier atomic propositions, but with truth values that depend on the values of the variables. Write A of X for an arbitrary atomic propositions. Let A of X denote X plus 7 equals 10, where X ranges over the natural numbers. A of X is true if X equals 3, otherwise false. So, A of 3 conjunction negation of A of 4. Let P of n denote 1 plus 2 plus so on and so forth plus n equals n times n plus 1 divided by 2, where n ranges over the naturals. B of n is true for any value of n, so B of 27. Add this to the language of formulae. P of Q is average with A of X. True, false, negation of P, P conjunction Q, P disjunction Q, P implies Q, and P if and only if Q. If P is a formula, then for all x P is a formula. So here is the definition. For all x P is true if and only if P is true for all values of x taken from its specified domain. Sometimes we write P of x for a formula that might mention x, so that we can write P27 for the formula with x instantiated to 27. Then if x is ranging over the naturals, for all x P of x if P0 and P1 and P2 n, or if x is ranging over red, green, and blue, then for all ax P of x if P red conjunction P green conjunction P blue. If P is a formula, then exists X such that P is a formula. So here is the definition. Exists X such that P is true if and only if there is at least one value of X taken from its specified domain such that P is true. So if X is ranging over red, green, blue, then there exists XP of X if P red, disjunction P green, disjunction P blue. Because the domain might be infinite, we don't give truth table definitions for the symbol for all and the symbol there exists. Note also that we don't allow infinitary formulae. I carefully didn't write for all xp of x if p0 conjunction p1 conjunction p2 and so on. Summarizing, the formulae of predicate logic are the terms of the grammar. P and Q is average with A of x, true, false, negation of P, P conjunction Q, P disjunction Q, P implies Q, and P if and only if Q. For all xp, there exists xp. Convention. The scope of a quantifier extends as far to the right as possible. So, for all x, A of x conjunction B of x is for all x the quantity A of x conjunction B of x, not the quantity of A of x conjunction B of x. Other convention. Note that always parentheses for all x of P. NRE atomic predicates A xy, B xyz. Regard are all P and Q as zero-ary atomic predicates. Equality as a special binary predicate E equal E prime, where E and E prime are some mathematical expressions that might mention variables such as x. And similarly for less than, greater than, less than or equal to, and greater than or equal to over numbers. E is not equal to E prime if E negation E prime. E is less than or equal to E prime if E is less than E prime disjunction E is equal to E prime.